Here we go. So, hello everyone. Thank you for joining us on this interesting podcast, which I think everyone should in the quant world, or especially if you're looking to study in this field, which will help to define more broadly, or more specifically. So, I have three interesting guests. Dimitri and Nick and Anupriya. So maybe each of you could briefly explain a little bit what you do and why we should be listening to you and what's your relationship to the what we then start talking about it. Dimitri?
Okay, I'll kick off. I'm Dimitri Bianco. I run a massive YouTube channel. We're almost at 15,000 subscribers, over 1 million views. I've also worked in the industry for quite some time. I'm equivalent to an associate director or senior vice president in the banking industry. I've worked at a variety of different regional banks. I've covered everything from market risk, operational, credit, and PPNR, mainly focusing on the regulation side, but model development and validation. I also work with a handful of universities across the United States, advising them on financial engineering education and best practices, as well as helping them somewhat with student placement.
Nick?
All right, my name's Nick Roca. I've been with SEI Investments my entire career since graduating from the Lehigh Masters in Financial Engineering. Prior to that, I did the IBE program at Lehigh as well in systems engineering. I've been with SEI in my 10th year now, and if I had a theme to my career, there would probably be portfolio rebalancing. So I started mostly in technology, doing massive rebalancing for banks and advisors, 50, 60, 70,000 plus portfolios, and nightly batch work, and optimizing those rebalancing algorithms. Then I had an opportunity to move to the investment side and actually helped a senior portfolio manager who was a quant launch some of our factor-based funds. So I worked in those funds directly, both in alpha signal research and portfolio construction. We were kind of just a two-man show for a few years. Ultimately, that team really grew and expanded and moved to the UK. I stayed here, and I still work on a lot of quantitatively focused applications in our investment management unit's technology platform. So I kind of oversee development there of some of the more quant heavy projects, and yeah, that's kind of what I've been up to for the remainder of my time there.
Yeah. And Anupriya?
Yeah, thanks, Patrick. Thank you so much for this session, arranging this conference, and I look forward to being a part of it. And Nick, it was wonderful knowing about you. You kind of fit our target audience, so I hope I do not start pitching the courses to you. But yes, to talk about quantitative, actually we started as and we still are one of the leading HFT trading firms in India. It's called iRage, and it was started by technocrats who were working in financial markets. And as initially it was an advisory, and it turns out that there were these different skill sets which were required to manage an algo trading desk. It's a combination of mathematics, then trading, and also technology. And that is how Quant Insti came into the picture. I have been in Quant Insti for 9 years, and before that, I was trained as I finished my master's in maths and worked in Citigroup. But since last almost 15 years, I've been in education. I've worked in K-12 as well for 5 years, and since then I've been in Quant Insti. So
Great.
That's about me.
I guess so. The first question, I'd like you to address is what is being taught, and it's probably a question more for Dimitri and Nick's the background, but what is being currently taught in those programs?
Can you define those programs?
Well, the financial engineering / quantitative finance / mathematical finance. What are the other names? Computational finance type of program. What is it? What is your typical?
Okay, I can start
Since
off.
I know you went to a bunch of people. So.
Yeah, I can start off with this. I think it's changing over time, and that's an important aspect. So when you view financial engineering from a core perspective, you look back pre-2007, 2008, so before the crisis, the big boom was going to be derivative products. So you start looking even further back than that, you start looking back like the Black-Scholes, like late 70s, early 80s, and the 90s, we see a boom here in Wall Street, right? You're looking for quants, and what are you hiring? You're hiring PhDs in physics, mathematics, and that was kind of the focus. As we move towards, like, I don't know, early, late 2000s here, we're seeing financial engineering programs boom. And a lot of that focus was around stochastic calculus, derivative pricing, very mathematical focused, again, with a lot of statistics, and that was kind of the main core. And then I think as we're moving forward in time, now computer science is playing a bigger role as we're seeing more automation, right? Algorithmic trading started coming around in the 2000s more so than it had prior. And so I think today's programs now are even changing more where we see more focus on data science. And so I think the question is where does financial engineering fit in this structure? But I think a lot of programs now have started to deviate where it's like you're trying to teach a little science, a little statistics, a little mathematics, a little computer science, and every program is so vastly different, it's hard to even select the program, right? Because all the names screw it all up, right? Financial engineering, quantitative finance, all that. So it's like, which program do you want? Is there really a difference? So I think currently what they're teaching is data science, machine learning is the big focus. They're kind of getting away from what I would consider actual financial engineering, which is going to be derivative pricing, engineering financial products. And then I think statistics is also taking a big hit, and a lot of this is being skipped over in current programs.
Yeah. Nick, when you were in the program, what did you study when you?
Sure. So first off, that was a great, I agree with like everything Dimitri said. I think it reflects my own experience. It was stochastic calculus and derivatives programs, an advanced fixed income course, coming up with all these crazy derivative strategies, and then, the hardcore math. There was a random process and applications grad level statistics course that we had to take. That was pretty rigorous. So yeah, I think Dimitri pretty much nailed it. So I graduated in 2011. That was really the curriculum then. We had a capstone project as well, which was cool. And that gave us a chance then to incorporate some computer science. We chose to do our project in MATLAB, and it was computationally heavy. Of course, now Python is where everybody is. I've worked a lot in C#. And then, of course, database, SQL, whether you go Oracle or Microsoft, you really ought to know one of those. So I don't really think I could add much to Dimitri's answer, except to say that, I do think I'll emphasize the computer science piece of it a bit more, that has been an awesome skill set to expand on in the industry for me, and something that I think that a lot of the programs probably need to focus on a bit more. I think you can't, especially when you're starting out your career, like you can't overemphasize the importance of the automation piece, because you're going to come in and you're going to have to do a lot of things as kind of a junior analyst. And the more productive you can be, the more you can even use VBA, Python, or, pick something apart using computer science skills. The more efficient you can be, the more productive you can be. I think those things all really help you stand out, especially in the early going.
So it would appear that they started you as the idea of, as David, you mentioned, a quant working on the math component was key, because we had to come up with all these crazy derivatives, and then somehow exotic trading and all that. And then, of course, the market collapsed, I think, twice. And now it's becoming, right? You're right. But yet, Anupriya, what are you seeing on your side? Because you seem to be focused on something very specific. Anupriya, can you hear me?
Yes, I got locked out for a minute.
Okay. Now, what I mean by that is, we went from wanting to produce lots of math-heavy, structure-driven employees, analysts, to now becoming more data driven, because the market has collapsed so many times that we don't need that many exotic derivative traders anymore. So we need more data driven people, or big data, or machine learning and things like that. But what is your take on that? What are you seeing?
Yes, I agree. So I have myself done a bachelor's and master's in mathematics, and obviously I was at that time very young. But when I went to the job, in fact, it was from one of the best universities in the country. I felt myself under-equipped to perform on the job. Things have thankfully changed a lot with so many open courses now which are available. However, I feel it's very important with the capstone projects and with actually working with data to apply the maths and the theory to come up with solutions. All the analysis is actually driven on problem solving. Ultimately, you want to either price something, or you want to do better risk analysis, or you want to come up with some kind of strategy. Whatever it is, it's a problem driven approach, and that has to be kept in mind with whatever mathematics or statistics or theory you are learning.
Can I circle back to a comment that Nick said as well? So I think it's important here to differentiate quants from implementation teams. And Nick was like spot on exactly what he said with learning to code very well, and learning even like computer science, which is outside of coding, understanding structures and servers and putting all the languages together. It's important to understand how to do it to become more efficient. As he's pointing out, right, you can do things much quicker, you can do a better analysis, it makes you quite well. But I think now we're seeing markets are splitting, where you have implementation roles that are completely separated from the quants. Where back in previous times, they were all kind of one job. And so for us, like, I'd rather get an undergrad, a master's, or a PhD in computer science to do implementation. But I think they're two very different roles. Again, smaller firms might combine those. So you definitely need to know C#, C++. And in my grad program, we did use the Boost library and actually programmed out all of our stochastic equations and did stochastic calculus in C++. But again, I think it's for students looking for education and jobs, is trying to figure out, are you shooting for a smaller firm and you need to have that diverse background, or do you need to learn coding to the extent of being more efficient, which is, I think, as you pointed out, something that's missing in a lot of programs. But again, how far do you take that programming? Because I see a lot of students with computer science degrees thinking they can be quants, and yet they're missing a lot of math and stats behind the scenes, which is kind of that meat of why you need that.
Yeah, could I would piggyback off that just to confirm it. So, when I was kind of there at the genesis of our real quant offering, and there were like 2 of us in the US working on it. So we had to be, very generalist. I would say what I've seen outside of, my firm and bigger firms is really the role we had, because we did have at SCI, we have an implementations team, but we really were quant dev and research in one team. But a lot of places will have research, quant dev, and then an implementations team. And unless you're actually, it's kind of like a sliding scale. The more you go towards implementations, that's like pure coding, understanding accounting engines. That's like, doing attribution reconciliation. That's like a whole nother area. But quant dev has dev in the name. That's where you're really going to need to be strong in like database and coding. But you need a lot of quant knowledge, or you won't get in as quant dev either. And then, yeah, if you specialize really in just pure quant, you're probably like in research. Mm-hmm. You probably need to know Python at a minimum there, but a specialized quant firm is probably going to try to get as much of the busy work or implementation work or whatever you might see it. They want you to focus on generating alpha on that team and finding, factors or signals that are effective. So I couldn't agree more. I think the bigger the quant firm, the more specialized, and the smaller, the more generalized.
Yeah, good point.
Yes, I agree. But even in smaller firms, it is possible that developer is different in the sense the person who actually codes the strategy. However, that comes, I believe, at a later stage. At least when you are analyzing the data and you are back testing, even then you need basic coding skills. And when you know that, okay, this strategy is good to go in the market, and we need to work with the live trading system now, then probably the developer will come into the picture. But I feel even if you're joining a smaller setup, the programming skills are a must. I guess that's what you also meant, right, Nick? It's very important to, you can't get away. In fact, even other fields now everybody, even in art or marketing, everybody is now becoming a programmer. You have to. There is no
Right.
other.
Go ahead, Nick.
I would agree. Just I mean, if you want to be like, this is just my opinion, but if you just want to be eminently employable, like let's say you're kind of a risk averse person, getting the computer science foundation, I think it ports to so much, like Anapriya just said. So I don't know. I mean, I'm kind of maybe at the risk of being a touch philosophical here. Like I'll sit back and think, if I could do it all again, would I build a really strong computer science base and then the math on top of it, and then the finance, which I think that it's probably learning the finance is the third piece of this that we haven't talked a lot about, and it's in the name of the degree. It's very important, but I do think that the harder the skills, like the more it's hard, kind of hardcore math or computer science, those to me those have like a steeper learning curve. So like if I think it's easier to take somebody that's really strong in computer science and math and teach them finance than to take somebody that's never seen any of that and, is just a more traditional finance major and then say, hey, you need to learn computer science and math. And I do see going back even to the high school and earlier, a lot of education programs introducing computer science earlier and earlier. So to me, this is all kind of like painting a picture that computer science might be really the foundation for so many fields, including quant finance. And then that math is probably, neck and neck with it, the most important thing. But, that's a very specialized set of math skills, a lot harder to port to other jobs. So to me, if I was like prioritizing it, I would like really nail the computer science side of it, then quickly go on to the math side of it, and then pick up as much of the finance, through reading, through talking to people, through networking with people in the industry. Just I think you have to be naturally interested in finance to like want to be in this field. So that's kind of just some stream of consciousness thoughts on all this.
And I think it's important though to define computer science, because I see a lot of people saying computer science is programming. But for example, if you're going to be working in implementation, you need to know the hardware inside and out. And even for example, in Python, right? AMD was far worse than Intel for processors, a few years ago. But again, Python's changing and AMD's adapting, and now they can run the same parallel processing between the two. And again, I'm by no means an expert on hardware, but I think coming from a computer science side, if you said you're computer science, I would expect you to know everything about the servers, the processing, what you have set up, why you have it set up, how are you beating the competition based on your hardware, how do you integrate that coding into that? Because how you set up your programming and code for optimization should be far different based on the hardware that you have set up. And I think a lot of times in the industry, we keep saying computer science, but it's hard. What is computer science? It's not necessarily just the coding piece. And I see a lot of people say they're computer scientists, but they're really not computer scientists. And it's kind of like, degrading a bit to computer scientists, because like I tell them I know nothing about, computer science. Oh, I can code in C++, I can code in C# and Python and R, but I'm definitely not a computer scientist in any stretch of the imagination.
Dimitri, would you consider some of that computer engineering more on the hardware side? Because that is important. Like we have an entire team, that they do server optimization and things like that. And, like setting up a Tomcat server or IIS and then making sure it's configured. I mean, you could get a PhD in configuring Tomcat, like to make sure that it's configured to run your services or however you're implementing your program. So like, I mean, the complexity on the computer science or computer engineering or IT side is like endless complexity.
Right, but I would just argue like an implementation professional, like a true professional, is someone who actually understands how to write the code to optimize based on the system. And from an industry perspective, I see a lot of people saying like, oh, I'm a computer scientist, and they can program in maybe 1-2 languages. And then I start asking about, hey, I had a meeting, so I've actually met with some of these companies. I've met with AMD, and we're trying to find some configuration to optimize server performance for the implementation team. It seems like then the quants are like clueless, like they don't understand like why that makes a difference between running it. But when you start bringing in true implementation professionals, then they start going, oh yeah, we had this hang up and we had this issue with the server. And then they start asking these detailed questions. And I think it's important to differentiate. Again, a small firm, right, this might all be one piece, or you might have an architecture team, for example, right, setting up servers and managing all that, which is, as you mentioned, even a different position. But I think it's important to differentiate between quants and implementation, because I get a lot of people that say they have a computer science background, and then when I start asking really detailed questions like about boost libraries or about, I don't know, memory allocation, it seems to go right over their head as if they've only learned to program in Python or maybe R or something different, but they're not, I don't know. I would consider them computer science experts or professionals.
Yeah, no, that's fair. I mean, we do see some of that, which is, oh, sorry, go ahead, Priya.
No, I said I agree with Dimitri. I think we should differentiate. And in fact, the roles are also very different for implementation team and the quant role. However, I would say that even a quant needs to have basic programming knowledge, not an expert in computer science, to do the kind of research they are required to do. So
Right.
from that point of view, I think I agree with Nick that every quant education degree program should have some focus on, and preferably on the new languages, because there was this was R, and then now we have Python. Before that, we had, I think, SAS. I was trained in SAS 15 years back, more than that. So, and now very few companies are actually using it. So that's
Yeah,
how.
yeah. I would agree, but I mean, on languages, I stick strongly behind C++ is the king. I don't even use it in my daily job, but I think if you learn C++ first, it makes the ability to program in like Python and R and other languages so much quicker. And I hate to say it, but Python, I think, is a fad. It's like every language. We were so excited, about C++ 10 years ago. Then it was C# was awesome. Then we jumped into how R is going to fix everything. And now we're onto the Python boom. Like, it's going to change. So it's like, it's hard to say which language is best overall. But I think having those foundations, kind of as Nick pointed out, right? Having that foundational course, definite training them in the current language would be a good idea. But having that base understanding in general.
Yeah. A lot of it's fit for purpose. Too. I think like if you're, let's say you're taking a more fundamental approach, like a factors-based approach to quant, and performance isn't everything, but you need you need something that is a little easier to support at like in more enterprise level, and maybe like absolutely bleeding edge performance isn't as important as, say, it might be in a high frequency trading algorithm or something. You might opt to do something in C# and some of the specialization around, hey, how fast is my algorithm going to run on hardware XYZ running, certain software, understanding all of that may not be as important to you. That's where like having really good leadership, I think, at least in planning out a quant team is so important, because they need to know like what's important to the success of your strategy. Like, if it's performance, you'd better know all those things down to the last, line of what's being put in there, because milliseconds could kill you. But you're more fundamental, it might be more important to make a system that's super easy to use, scales well as you add more strategies to it, gives really clear attribution and insights into what's going on in your strategy. It's just never like as straightforward as like one size fits all. And I think each firm is kind of going to quickly, hopefully, tell you like what's most important to them.
Right. That's a good point.
So this is a little bit worrisome, because Dimitri started so well talking about what this thing was supposed to be originally, when all the programs were created. And you notice we're talking really about implementation, we're talking about data, programming. We're not saying anything anymore about trading per se, or finding finding the truth, quote unquote. So is this what's happening? That because then once you're there, you say, okay, so you have to be programming. No, 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 no. You don't. Please don't do that. Oh, okay, so I have to know programming without being a programmer, but I'm not doing exotic trading anymore. So, but I'm still a quant. So, and I guess that's why we don't really know what to call it anymore. And the risk is that we get lost in the wilderness out there by having program that maybe do lots of lots of programming and less math. Is there, because Anupriya, what are you teaching in your in your center there in Quant Insti? What are some of the topics? I mean, do you have any finance courses?
Finance course?
Yeah. Do you have finance courses in Quant Insti?
No.
No. So that's
Our
out.
focus is yeah, but every course is actually a combination of maths and technology, where we are teaching in Python, and I can give you the reason for it. And the third bit of it is finance. So, but like I said, the focus is on problem solving. Let's say what you want to do is at the end of the course, which is a short course. It's not like 30 hours, uh, 30 hours semester kind of program, but a short course which you can do while you're working. So let's say you have to create a strategy using momentum trading, uh, uh, trends and theory. So you need to learn the theory bit of it, how what is momentum trading, what are different types of trend following paradigms, and you need to take the data and apply that those theory using a language or a platform. So it can be Python, it can be R, but on our platform we are only using Python because of a simple reason. One, Python is easier. I have learned C++, Java, Python, R, and honestly, if you have to write an entire piece of code and then run it and then debug it and then run it again, which happens in C++, it's much more difficult than doing it line by line execution, which happens in R and Python. It's much more intuitive. It's very closer to English language. Yes, you can always say that anybody who has coded in C++ will be able to code in Python, and maybe not vice versa. But the thing is, what I believe from my experience in education is also that the aim is not to make things much more difficult. It's not to give a very high targets, but it is to keep going, keep achieving at least small things, so that you build that confidence and you never stop learning. So for example, even if you start learning with Python and you are able to implement actually deliver something, implement a strategy, uh, if later on the challenge is for you to learn C++, I believe you will be able to. Whereas if you start with something much harder and you fail there, it might be difficult to pick it up later. So the and I agree with what you are saying about maths. Is Are we losing the focus, and are we not studying maths anymore? And like we already established that it's very important to have those core concepts set, and those will be difficult to pick up later. uh,
but I think, it matters. It differs from individual to individual. Every individual have different learning styles, and those who actually want to get into the core bit of it, there are so many financial papers, research papers to study. um, so yeah, so that's why I think the master programs are also very relevant, because they give you that core training to work with so much, the pure maths of it, which is also, I think, relevant for certain, we need to have that kind of strength as well.
You know what, Elian, because now we're getting into the interesting topic of, learning versus training, right? I know that when Nick went to the program, I mean, it was mostly learning, right? The principles, and then I think you had one capstone, but also the bulk of your work, and I think that's the case, Dimitri, right? That everything is mostly you sit and you learn the principles, and but Musk, for example, not too long ago, he had an interview with the Wall Street Journal, and he basically said, less MBAs, less presentations, and more doing.
So I would argue this on, there's a two-piece part to it. You have academic masters, and you have professional degrees, which I'm just going to call them what they are. They're vocational training. An MBA is vocational training, whether you like it or not. That's just what it is. Even for hiring on a lot of quants, most financial engineering programs I will not hire from. I won't even consider, because it's vocational training and it's so applied to one very specific thing that you can't stretch. And so my argument would be is that while you do need some of that professional industry experience and trying to show the application, if you have someone who's very academically trained on just the theory and the skills themselves, I can train you to do anything. So I've worked in credit risk, I've worked in market risk, I've worked in operational risk, right, and PPNR risk. Most people can't do that. I look at a lot of these different backgrounds. It's because they don't have that theoretical grounding where they can take the math and the statistics, more importantly, and apply that to any of these problems and come up with actual worthwhile solutions for the problem. When I see a lot of students nowadays, it's quite frustrating from an industry perspective, is you get them and they show up and it's like they've been trained to do A. And when you try to say you have to do A plus B, it has to be this bigger scope. It's like you have to sit down and retrain them to do an entirely different job because they're only trained to do one thing. And this is my concern now with a lot of the programs. They're deviating into machine learning and data science. But if I wanted a machine learning data science expert, I'd go out and hire a data science master's. And so I think it's important to differentiate where a program's going, what's more important. Kind of like you're pointing out, what's more important, the theoretical construct or the application? I mean, I'm sure people on here disagree with this somewhat, but I think the theoretical construct is actually the most important piece for a successful career throughout the entire career for a quant.
Nick, what do you think from a practical
experience? That's interesting. So I almost split this into like two categories based on what Dimitri's saying. One is like an abstract, if you just understand the high level abstract concepts, then you can get the applications, and that piece I agree with. I'll maybe play devil's advocate a touch, because I think I mostly agree with Dimitri, but I'll kind of bite and say that sometimes you'll see postings out there where they are just, somebody left a firm and they just need like somebody that knows how, I don't know, Axioma works, or they need to know how, this trading or accounting engine works. And maybe these are not in pure research, but these are more in the implementations or quant dev side, where they'll say, hey, here's our technology stack. And, maybe if you've been trained on that specific stack, boom, like you go to the top of the list. So I think that, yeah, for education, obviously, I think learning the abstract concepts that are at the core and the foundation of all these careers is definitely most important, I think, when you're a student. But, as you kind of move in your career, you're definitely, you'll just see it out there. A lot of postings looking for somebody with a a very specific, like, hey, do you know how this works? We need somebody that knows how this works. And, you know, start Monday if you know how this works. So I don't know. I think that a combination of the two, as you know, maybe start with the theoretical, but as you go, having the applications are you know, probably really important, you know, to your career, because at the end of the day, you're gonna be working in applications. So
Yeah.
that's
So
yeah.
so let me be controversial here, because then if you're saying that, if that's true, and what if Dimitri's saying is true, meaning, you know, you want to study the principle, the basics, I mean the theory, so that you may not use all of it, but just in case you're able to, you're not just programming and no machine learning. But then if that's the case, I mean, some of these principles have been around forever.
And unfortunately,
Everyone,
the majority of people out there graduating from these programs, while the information is freely available, they still don't implement it correctly.
okay, so the argument to say, yeah, but you know, the book is out there.
Yeah.
There's nothing new. I mean, one school is not going to teach you any differently than another school, at least the principle of it. So what makes the difference? What's the quirk then? Why should I take this program here versus there? Because stochastic calculus has been around forever, and they've got thousands of books on them. And if I'm not going to be focused on practical implication, which that's much more difficult to individualize, you know, so then
I would
What's the difference?
argue the application of the methods I can teach you in like a day. Like if we have a new problem, I can explain. If someone has that really strong theoretical background, I can explain it in a day, and they understand it quickly because they understand all the math behind it. The issue I have is when you get someone and they have all this application and industry practice, and I come in and tell them like, well, what you learned in school is not actually correct. That's not how we do it in the industry. I mean, your teacher's nice, but that's not real application. And then you change it, then I have to go back and do all this layering of explaining exactly why it's different. And I even have students argue with me and will say, you know, well, I know this friend, or I work in a different country in the United States, and all we need to know is to code that in there and I get a result and I'm happy and I'm fine. But the issue is comes back down to this core concept in finance is anybody can build a model, but is the model correct? And how do you judge that, right? I mean, I could build a model and it performs, I don't know, say at 90%. Nick builds a model, it performs at 95%. So his model is better than mine, let's say. But at the end of the day, if I don't know Nick, right, everyone's going to think I'm a genius, right? I hit 90%. And I think this is where the fundamental problem comes in quant finance as well, is if you take everybody and they have a low level knowledge, there's no one to judge what is correct and not correct, and you have no alternatives, everybody looks great. Like you don't even need a master's degree. Let's just get an undergrad degree. We'll just throw them in there. They'll model things in Excel, come up with strategies. And hey, I mean, that's traditional finance. You don't really need all that additional programming and statistics and math, right? It's just too much to do. And so I think the fundamental piece here is who's setting that level for the firm. I mean, senior management should be setting the standards, obviously, at some point. But again, how do you measure the quantness of it and the correctness of it? Because the vast majority of models and the vast majority of research papers and presentations you see online around quantitative finance are wrong. There's so many flaws with the assumptions they make, and they don't even state those assumptions clearly. And I think even like the Black-Scholes is a great example of this, right? It has flaws, it has assumptions, but they clearly state those flaws up front. And that's kind of the defining characteristic of judging how well your model is kind of structured.
Yeah, I'd piggyback. Wow, there are like a bunch of things there actually that I'd piggyback off of. First off, thanks for giving me the 95% model.
Yeah.
I'm not sure I deserved that, but the what I'll say there though is yes, I agree. It's on the quant leadership to set, you know, how are we validating these models. A good quant is always extremely skeptical. If you get a good back test, I mean, be wary of the back test. That's something that I think everybody's probably heard in the industry. You should be extremely skeptical of a good back test, you know, and try to beat it up. I think really though, what maybe Dimitri's getting to is like first principles thinking. I mean, you shouldn't be data mining for a signal that just works and then trying to justify why it worked. I think maybe that could, maybe some people are successful doing that, but that's like, to me, a bit, in my opinion, a little dangerous. I think it's way better to be a first principles thinker and come up with a theory that has some fundamental reason for why it should work, and then start building your model that way. And that's where that good leadership and thought leadership should be coming, saying, hey, we think that this should work because of these logical, conceptual, first principle reasons. And then you start building your model, and then, you need to be skeptical at every level, every result, question everything. So I would agree entirely. I think, coming out of school, just, being a skeptic and not trying to get the best model, but trying to just, learn how the models work, where the assumptions are baked in, when would your model be wrong? When would it perform badly? What could derail your model? Thinking through all those things, it's just like a really, really important thing, versus, hey, I just want to get in there and start coding and, set it up and then look in like FactSet or BlackRock or Bloomberg and see what my performance is. And then, I'm checking my alpha of my model every day. And then, that's probably not the most productive thing to be doing.
So I guess if a student is looking at this and saying, okay, so what should I be doing? Well, it's not so much what you should be doing, the type of program, but I guess you need to be aware that the industry is changing. You need to be aware that, be careful. You do need that theoretical background, because even though the market is pulling you one way, as Dimitri mentioned, yeah, but it may, Python that's today. Years back it was Fortran, and who knows what's going to be in the future. So then you end up with this thing and say, great, we don't use that anymore. We're using something else. So, but you need the fundamentals that have been there for years and years and years. And I guess it depends how well you understand the material and how well it's being taught to you also, obviously, and how, and I guess Anna-Priya would disagree, how when you teach this to students, because I'm assuming that, do you have classes? Is this online, or is it your courses that you're giving at Quant Insti? Are they physically in the classroom, or?
We do have a classroom, but everyone prefers it to attend online. So there are two types of courses. One is classroom based, and another are self-study. And we have found even in classroom based courses, students prefer to go back and self-study at their own pace. They want to see the thing. So what I realized in this conversation, that all of us are assuming that that students will be implementing what Dimitri said, what Nick said, is the assumption that whatever we have learned, we will go and implement. But actually, the truth is far from it. The truth is that what we learn, a lot of it, especially if we have not learned to implement it while learning, then we forget it. Unless you keep going back and reading back the books. So that's why if you read a book 2 years back, and if somebody asks you what was taught in that book, you will, unless you have implemented any of it, you might not remember it. That's why it's important to think from the learner's point of view also. Not every learner can understand the abstract concepts, or and in fact that doesn't mean that they cannot understand abstract concepts at all. What I mean is, they can understand it if it comes with the implementation bit of it. So what it means is, we can obviously, as educators, we can say, no, it is important to teach ABC, and you have to go through so many books, and but by the end of that education, or let's say after 4 years of it or 10 years of it, how much of it is retained? That is I think a very important question to ask. Not just after 15 years, after 20 years, since the market has changed, and we are preparing our students for that change, right? So we need to ask that question, I think, all the educators.
And I think for selecting programs, it's a challenging aspect because, right, we require that master's, at least in the US, as that minimum, that bare minimum. And yet a year to year and a half, I feel is way too short. I think master's should be at minimum 2 years. But even at 2 years, right, you can't learn everything. It's so hard to learn everything. And I think it's important to look at the different masters that are available and try to figure out where are those schools placing students. And if that is the career path that looks interesting to you, then go after that program. So if this program is placing a lot of students on, I don't know, let's say the quant research side or the trading side, and you want to do that, and that program's placing a lot of students there, that's where you should go. But I think you should be aware of it, because realistically, what are educational institutions? They're money-making machines. They're out to make profit. They're not out really to educate you per se. And even for myself, for example, I'm trying to do some online education with YouTube and Udemy and other things like that. You can make far more money making fun, flashy, exciting videos and tell people how to trade the stock market than I can. I mean, I published a video on how to program in R. What is the stochastic processes? How does it apply to finance? They might get 150, 200 views, but no one wants that rigorous material. And so I think as an educator and as universities as a whole, you have to kind of judge and see, are these universities providing you something fun and exciting, but it's not really applicable to what you want to do? Or are they providing you something that's solid that leads to the career that you want? And of course, every student's different, right? Where you want to end up is going to vary from student to student. But again, trying to align that university's goal with yours, I think is important, but also challenging because most programs are kind of lying about what they're actually providing you.
You know what, Dimitri, this is totally true what you say, because if you're a student and you say, okay, Dimitri, I'm going to listen to you, I'm going to go on those websites and I'm going to see what I'm going to be doing. Well, no, I mean, well, the number that is used is how many of the students work. And in fact, that's how they use the ranking. Are 90% of your student employed? Yes, 95%. Great, 100%. Fantastic. But there is no ranking that says, hold on. But what are they actually doing? Are they quants, or are they programmers, or are they data scientists? Because what are we actually, and when you go on the websites, you don't often see, I mean, you see one student with a tie, working or whatever, but you don't see all of them, and you don't get to know what they're doing. And maybe you're right, that may be the key to say, okay, because that's the only way you're going to know what you're truly going to be doing.
Yeah, and I think part of it is that definition of what you do. Because a lot of people reach out to me and say, Dimitri, I want to be a quant, right? And they explain exactly what they want to do. And they say, oh, I'm going to go to this program that's really well ranked. You recommended it. I said, hold on, like, what do you think being a quant means? And most of them think it means being like a trader.
Yeah.
I don't view traders as quants. It's a very different skill set. And if you start Googling online, right, looking at these top hedge funds, for example, their traders aren't quants. They come from business backgrounds. They don't even have the math training for it. So it's like, if you want to do that, I have like nothing against that. It's an awesome career, but perhaps these other programs would be better. I think it's the most challenging piece is, again, even for the student, defining exactly what you want to do. And that, I think, would determine which program is best. There's not necessarily like amazing programs and terrible programs. But again, if your target is quant finance, a lot of the top ranked programs for quantitative finance and financial engineering aren't going to land you that quant job you're expecting.
Yeah, actually, that's a very interesting point. In fact, in trader education also, the thing that sells is, I made so much profit, and I started with $100 and now I have $1 million, and
yeah.
Promises which are totally bizarre. So I agree, that I think that's kind of I think we should be very honest in what we are delivering, what we are promising in any education. Ultimately, the hard work is to be done by individuals. The good thing about education is it can come anytime. So, like I mentioned, I go back and read the books that I've read 5 years back, and when I read them again, I realized, oh, I didn't understand 50% of it. But the only thing is that I was not ready at that time. But the book made me fascinated. It fascinated me, and it didn't left me with kind of thing that, what is this? It was something that I will come back to again and again. And that, I think, is the role of education, to enable learners to come back to the same concept, read it again, understand it better. Ultimately, the core is same.
Yeah. And I wish programs would just label the program correctly. Like, that's the biggest ploy here. I hear people like, this is the greatest quant program. And I'm like, those students, so behind closed doors in my LinkedIn account, right, their students are messaging me and I can tell you they're not quants, but it's called financial engineering or quantitative finance. It's like, it's an investment banking program. Like, it's an MBA, it's a feeder program.
Yeah, I'd add a few things to that, maybe to tie a couple of things together here. One quick hitter, maybe to Dimitri's point, look at most of these programs have the syllabus or like the classes you have to take online. So just go see if they're like actually quant classes, or if they're not. But the other big takeaway I'm kind of getting from this whole conversation, like if I'm a student, so what's actionable from this conversation? I think like it's kind of like you almost need to kind of cross-train yourself across the abstract and the learning and then the application. So like if I'm a student going into a grad program, a couple things I would say. One, if you're looking at master's programs, let's say you pick a good one, you go read the syllabus, you talk to some people on LinkedIn, you find a good one that actually is quant and you're really happy with it. I still think you're going to be surprised that you're going against a lot of PhDs for a lot of quant roles. And I think so, it's not a slam dunk. You may not be starting with your dream job. So just keep that in mind unless you want to do a lot more school, which, hey, that might be the right thing for you. But what I would say is kind of, I think you need to complement the abstract with the application. So like if I'm a student, I think the smartest thing you can do is take the degree program that's hard skills, abstract concepts, true quant concepts, and learn how to think in school. And then, go get an internship or go network or, go, do some side projects in Python or whatever, try to replicate a 3-factor model, with available data online, go do some of that outside of school. And I think if you do the both, they reinforce each other, because actually some of the abstract concepts I understand way better now after a particular application that made the kind of the penny drop for me. But now I actually have cemented that abstract thought and I can apply it broadly, like Dimitri said. But as Anna Priya was saying, if I didn't do the application that made it click for me, I may have never understood that abstract concept. So I think doing both and using a really good program to learn how to think and learn the concepts and then complementing it with the more practical, that's like your best approach.
Yeah, I'd agree. I would also argue as a little bit of a disagreement with the curriculum. It is so hard to read curriculum now and to tell you if it's a quant program. And I'll tell you, this is because I've been doing this for 5-6 years now, 7 years. Quant programs and non-quant programs have gotten very, very tricky. So you'll have a really good top-rated quant program and they have all the curriculum listed. And it's like, okay, it's obviously a quant program. It's been in the industry for, I don't know, 15, 20 years, something like that. And you'll have a non-quant program and they'll have a bunch of like businessy classes listed. And then you watch next year, all of a sudden, all those classes, the same numbers, like finance, I don't know, 570 is now math 570. And they'll relabel them a little bit to articulate it so it looks like a quant program. And so a lot of students reach out to me trying to say, hey, like, is it real or not? And I hate judging it because, right, I don't actually know unless I could like go down to the school, sit in the class, read through the textbooks, right, talk to the students. And so it's so challenging to actually rank out these programs. And that's one of the biggest, I guess, struggles for people applying for education and learning as well.
Yeah, and that's what a lot of students probably also argument they're studying later on with program like such as quantitative, right? Which tends to say, okay, these are the things that people are actually using, but the thing is they need a lot of theories, right? To be able to handle it, because they say, I want to learn these things, I want to learn these tools. Yeah, but if you don't know all this that comes with it, it's difficult for you to grasp. So students, they want to give me something I could use right away. Say, well, yeah, because then I've seen lots of online delivery programs, apart from academics, who are very specifically driven in telling you, this is what the industry is using. That's great, but you don't see the slew of the background that you need to understand it as well.
And we, at least for me personally, I run from those students. When I see they're so excited to learn application and they're so hungry for it and they think that's going to get them the job, I'm like, thanks for interviewing. Like, I know you're not going to fit. I want that person that wants to dig deep in the math and the stats. I don't want that guy that's super excited, to make that $1 million or to make that big position. Because a lot of times for the quant perspective, if you're deep enough in the research side and the model development side and the validation side, you're so deep, you're not looking at that dollar value. You're looking at, statistical metrics and seeing if the application works correctly. And of course, like now I see, oh, we have, millions of dollar losses or whatever. It's like, whatever. It doesn't phase me. But as a student, you would be like shocked on like, you lost $10 million yesterday. But I think in a general sense, if you're really concerned about application, it's really exciting to you, I would actually encourage those students to go into finance, like traditional finance.
Yeah.
But
and
the quant side's good. Yeah, go ahead.
I'm sorry, Dimitri. And what do you think about that? Because this is your backyard.
I think can you hear me?
Yeah.
Yeah.
Yeah. Okay. Every individual, like I said, works differently. They learn differently. So if you can start with abstracts, work in a data-free environment and understand stuff, go through an entire machine learning book without working with any data sets or programming, excellent. But honestly, I myself as a learner would not be able to do it. I am a kind of a person who reads this much and then applies, and that is not just for finance or maths, that is for parenting. Like if I'm reading a parenting book on how to talk to your children, I will read one chapter, I will shut it down, I'll apply it for a month, I'll go back to the book, read again the next chapter, and so on. That's my style. Now the thing is, as an educator, it is our responsibility to be able to provide the content which can cater different type of learning styles. Somebody wants to yeah, please go ahead.
I would just disagree with I think we're defining application differently here. So when you say if you learn a concept and you use data and you apply it, like you're testing and seeing charts and seeing how it works, I would argue that's still theoretical. Like it's not an actual real world application a lot of times. So I agree, like programming and seeing how it works is important. That's definitely an important piece. Hi?
But how is that not a real application? I mean, if you're actually, let's say, even if you're working with black shows and you're then trying to apply it on actual data, how is that not a real application?
Okay, so I'll give you an example. Black Scholes is super specific. Okay, so that one has to have an application. You'd have to teach it alongside that. But if you looked at something, for example, how do you model the volatility within that derivative pricing? You can use real data. It doesn't really matter. It doesn't have any actual application to it, but you could also use any type of data. And it's important, I guess, if you tie in the finance piece of it, right, that's real. But what you're going to teach in school is going to be vastly too simplistic for application in the real world. So for example, a derivative trader that's actually building research models for these isn't going to build, for example, a simple Garch model to do volatility modeling, right? You might be using something more complex, like Jim Gatherall has the rough volatility model. It takes, again, all these layerings of stochastic calculus to understand how all the pieces get put together to have that implementation. Again, it's very controversial. A lot of people don't agree with the rough volatility model, but again, it's not going to be from an like the way I define it, it's not a real world application because it's not really how you would do it in the real world. It's just taking financial data, seeing, okay, this is a good approach and it works. And the whole purpose of that is only to learn that theoretical construct. If I was to teach you, for example, how to do time series modeling, so volatility as well, I mean, I could teach you industry stuff. No one's going to understand what's going on. It's going to be fun and exciting, but no one's going to get it because you don't have all those really, really simplistic, easy to understand applications. Because once you get to real world data, the data is not clean. It's not easy to process. A lot of the theories are really, really hard to see. Like I can't, for example, explain stationarity concepts on real world data a lot of times. It's too complex. So you have to go back into simple data pieces like economic data, which is really easy to understand before you can apply that to actual real world applications on how we would actually do that at a bank or a trading firm, for example.
I don't understand why can't we teach stationarity concept on the real market data?
You can, but again, what you're teaching, the level you're teaching at is not how it's actually used in practice. So for example, you can teach stationarity, but how does that stationarity impact more dynamic model structures? How does that impact stochastic processes models? How does that impact ARIMA, ARIMAX, GARCH? How is that going to impact all these very specifics within that model? And I can tell you 99% of everyone out there is not teaching stationarity correctly.
Dimitri, is your fear more that if somebody, sorry to just kind of butt into this, but like, is your fear here that like, if somebody came and said, hey, I learned how to apply one of these models you're talking about in the industry, that they don't conceptually understand it, you're going to think, hey, they just know this one really specific thing. They can plug the numbers in it and get an answer out, but they never, like, you have to go back to the simple, like, model and then like understand it at the lowest fundamental level and then build up to that industry model. Is that the fear?
Yeah, you're hitting it right on the head. And I would say it's a fear based on reality. So I constantly see these graduates from all these schools across the country that come and they work and they run some test, or they run some model and they say, this is what I was taught in school. And I go, great, it's failed. Go back and rebuild it. 3 more months of work. Well, now you end up in the situation where management's upset because now they wasted 3 months. Then they're upset at you because you wouldn't pass it. And then I'm looking at it like we missed very, very fundamental aspects here because they've learned how to apply these so blindly that they're not taking away that theoretical underpinning. So I agree with you on the education as well, your program, your education system, that it's good to use real world data and to kind of learn the basic concepts. But as you're pointing out, Nick, it's kind of that layering of like, you would need to start with something so simplistic with real data that in the real world, right, you would need to layer on years worth of classes, not necessarily like one application.
Right. I think that's actually compatible with what Anna-Priya is saying, because I think what Anna-Priya is saying is basically just, once you learn the concept, you have to go do practice problems and you have to go practice it, or you'll never remember it, or it'll never make sense, which I think's like very true. I think, Dimitri, you're just like more like the person that puts this specific model on their resume, and only has, 1 year of work experience. Like that's kind of a red flag, something like that.
Yeah, I was just pointing out that I'm agreeing with Priya, but I think what she's understanding is me saying is applications necessarily not different. Like we're agreeing on the same thing, right. But I just don't want, I see a lot of programs, so I can tell you big name universities that will say this is how it's done. And then they come in industry and it's not how it's done. But I definitely agree with Priya on like, you need to use data to actually see how it works, right? You can't just read the textbook and then theoretically understand everything.
Okay. I think it's, we could keep on going. But I think it's, hopefully when people watch this, they'll have a better feel as to, and I think what they're learning is be careful. Don't believe what you read. Make sure you go beyond, make sure you ask the right questions. And I see that with students all the time. And the question is, why do you want to be a quant, and what do you expect from this program? And a lot of people don't really know what it means. They say, I want to be a consultant. Anyway, this is a different topic altogether. Any parting words before we end the podcast?
Just to add what you said there, Patrick, in addition to that, you should also remember that education is a lifetime business. So if you have completed a degree or a course, that you should not feel that you are an expert. It's as we have pointed out, it's a layers kind of thing. So you read a book, you read it again, you do a course, you do it again, and even after that there are so many research papers that keep on coming in. I think it's very important to know that it's not over until the end.
Great. All right, everyone, thank you very much for your time, and hopefully we do this again later on to see how things have changed the industry.
All right, thank you.
Yep, okay. Thank you.